Hello team and welcome back to the channel. So in today's video we are going to get started with the EKS cluster. That means we are going to deploy the application that you have been constantly working on inside the Dev EKS cluster. Okay, that's where we are going to do. We are going to create the complete CI/CD pipeline, YAML files, and we are going to understand the RBAC also, how exactly it works and how we are going to be utilizing it, right? So make sure to subscribe to channel so that you don't miss out any of the videos. Also team, make sure that you have implementing a side by side following all the videos till day 4. Make sure you have implemented it, right? And this is the project that we are going to deploy inside EKS cluster, inside Dev cluster, right? Now one more thing team, as I told you today I'll be showing you which of the people have implemented this and posted on LinkedIn. So here we have the list. We have Pranay, who have implemented this and posted on LinkedIn. So many congratulations, Pranay. Then we have Khushbu, who has also implemented it and posted on LinkedIn. Congratulations to you as well. Then we have Satnarayan, who has also done the project, and it's like I feel very happy that you guys are actually putting efforts, learning things and implementing it so that you become very good at DevOps, right? Then we have 𝗕𝗵𝗿𝗀𝗃, who has also implemented. So congratulations to you, Saurabh, as well. Then we have Vivek, who has also implemented this and posted on LinkedIn, right? So and then we have Muhammad Adil Munir as well. So yeah, next set of leaderboards will be containing the list of people who have implemented this, posted on LinkedIn and tag me. So make sure to implement it. This will not only just show like give you an exposure to lots of thousands of people who are in the same domain, and I hope out of that some of them will be HR who can reach out to you for job opportunities. I hope so. Yeah, so yeah, make sure to implement today's video as well so that you can learn great things and good things, right? So yeah, now with that being said, let's get started. So team, first of all, let's talk about what exactly we are going to implement today. So let me give you information about step by step. First thing, we have to set up our Dev cluster where we are going to deploy the application. Second thing, we are going to create the YAML manifest file. Now let us understand why do we exactly need to create YAML manifest file when our application is already running using Docker containers. Okay, so first of all, let us understand what exactly is the problem that Docker solves. Docker solves the problems of portability. Like using Docker, we can make sure that we can share the Docker image to anyone and anyone can run the application on any platform irrespective of the platform, right? So Docker solve that problem, but the problem that will appear when you're using Docker, let us say that we are running application through Docker. So there will be 3 containers running, right? One will be MySQL, one will be front end, and one will be back end. Now in case of Docker containers, the thing is that they are running, and for some reason, let us say that one of the container, let us say MySQL container, crashed, right? So how do we fix it? So obviously since we are the one who is monitoring Docker containers, so what we have to do, we have to check the container logs, and then we have to either restart or based on logs we have to fix the issue, right? Similar kind of things can happen with any of these containers. So main problem statement here when running the application via Docker container is that you have to be present, or you have to be the one to monitor the containers 24/7, so that if any containers crashes or if any issue occurs, you have to be there in order to fix it, right? But that is the problem statement. So how do we solve that? So that problem statement can be solved using Kubernetes. Now in simple words, Kubernetes is what? Kubernetes is a container orchestration tool. What is the meaning of container orchestration? Now the word orchestration basically means management, right? So what Kubernetes does, what we ask Kubernetes to do, that we will create the, let us say that this is my Kubernetes cluster setup. Okay, next thing what we have to do, we will create the containers inside it. All 3 containers that we have for our application, we will create inside the Kubernetes cluster, and we will write some information about how the crashes, how the issues will be handled primarily by the Kubernetes. That means Kubernetes will be the one who is going to create the containers and manage them. When I say manage them, that basically means Kubernetes will be the one who is going to monitor the containers 24/7. If anything goes wrong, Kubernetes will take steps to fix the issues. If issues are not fixed, then we have to intervene. So here the benefit that comes is that we don't have to be present to monitor the container of the application 24/7. And you can understand that it basically reduces the manual effort to monitor the containers, right? That is one of the main reasons that we prefer using Kubernetes. Plus there are so many other features also that we get within Kubernetes, like security we get, proper management, observability, so many other things also are present, right? So that is the reason that we'll be using Kubernetes from now on. So first thing what we have to do, we have to set up Dev clusters. For that I'm going to use EKS, Elastic Kubernetes Service. Now why I'm using EKS? Because when you set up Kubernetes locally on your machine, again it becomes very hectic to manage the cluster. But when you set up the cluster on some kind of cloud platform like Azure, AWS or Google Cloud, it becomes very much easier for you to work with it, because most of the things will be handled by cloud team itself, right? Second thing that we have to do, so this configuration that I'm telling you, that like when we deploy the containers or create the containers inside the Kubernetes, how exactly it will be managed, how it's going to be created, all those things we define inside a configuration file known as YAML manifest file. That is a YAML formatted file. So we have to write that YAML file where we define everything, right? Like where you are going to store the username, password of database, what will be the table's name, what will be the Docker image used to create the containers, what will be the size of the container, how much resources it should be using, how much RAM and CPU each container should be allowed to use. All those information we are going to define inside YAML manifest file. Okay. Once we have created this, third thing that we are going to do is set up Jenkins SonarQube. Okay. Fourth thing, we are going to set up the CI/CD pipeline. CI/CD pipeline, so that we can deploy the application inside Kubernetes cluster. Once we have done that, then we are good to go. So this will be our Dev cluster deployment. That means we are doing the deployment for the first time in development environment to check if the application that we have created, if the YAML manifest file that we have written, it is working or not, right? That is the first level of deployment that we are going to do. So these are the 4 steps that we are going to implement. So first let us get started with creation of EKS cluster. So team, before we just get started, just to let you know, batch 10 of DevSecOps and Cloud DevOps is open for enrollment. It has 120 plus hours of content immediately accessible to you. Price is having a discount as of now, so you can enroll. It has more than 40 projects, so that will give you a very good idea about DevOps, different scenarios and different things, and everything is covered from scratch. So make sure to check it out. All the details will be in the description. So team, first of all, make sure that you are going on your AWS account. Click on launch instance. So here we are going to create one EC2 machine. Now this machine will be like installer VM. So we are going to execute all the commands to create the EKS cluster on this VM. Okay. But as you understand, if you want to create a cluster over AWS platform, then you need to make sure, and as I said, we are going to execute the commands on this EC2 machine. That means we need to make sure that this EC2 machine has the permissions to create resources on AWS platform. Right, so that also we have to implement, right? So first let us create Ubuntu machine, and size will be T2 medium, which is again more than enough for us. Make sure you are using Ubuntu 24.04 LTS version. Keep here we can select. Network settings, again we can select the one that we use, and storage I am giving around 25. Let us launch. So machine is created. Let us connect to the machine. Copy the public IP. Go to MobaX term. And let me create new session. SSH public IP. Username will be Ubuntu. Advanced SSH. We will select the private key. And we will give it a name. I'm going to name it as installer VM. If you want, you can set up a color also. I'll just go with this. So now we should be able to be connected to the machine, right? Now first command you should run sudo apt update. This is going to update all the packages and make them available or ready for usage within the this is machine, right? Now, as I said, we need to make sure that we are having this VM is having permissions to create resources over AWS platform. So there are two options that you can achieve that. So one option is that you can create a user, then where we have to create inside IAM. Now, once you have created user, you can assign certain policies to the user. These policies will be the one which provides permission. In policies, we can define that this user will have permission to create EKS cluster, to create EC2 resources, all those things we can define. Once you have assigned this policy to this user, then for this user, we can create credentials. When you create credentials for this user, you get two specific things: access key ID and secret access key. Once we have these two things, you can attach them using AWS configure inside your machine, and that will make sure that your machine is having EC2 machine is having permissions to create resources. This is the first option. Second option, for demo purpose only, for demo purpose, what you can do, you can create the credentials for your root user. Okay, and this is for demo purpose we are going to show you today, right? So how you can create the credentials for demo use root account? For that, you can go to your your like account name will be shown. Click on that, click on security credentials. Once you click on that, it will open my security credentials. Scroll down to access keys. Here let me remove the old one so that I can show you fresh. So I can delete this, the old one, and now we can click on create access key. Check this box and click on create access key. So this is created just to make sure that you have these credentials available for later usage. You can download the credentials in a CSV file. Click on that and it will be downloaded. So once you have that, then you are good to go. So here, next step, what we have to do, we have to install AWS CLI. Why we need to install AWS CLI? Because using that only you will be able to set up the credentials. So first I will install AWS CLI from this command. So let's wait for this. Okay, once AWS CLI is installed, you can run the command AWS configure to provide the credentials. Run it, and you can see it is asking for access key ID, which we can copy from here. Secret access key, which again we can copy from here. Then provide the region, in which region you are working. So currently I am in India, so we are going to select the Indian region, which is going to be AP-South-1, and click enter. Output format, you don't have to write anything, just click enter. Now in case you don't know like how to find the region, you can simply go in AWS platform. Here, based on your region, you'll be able to find code. For example, Mumbai, we have AP-South-1. Similar to that, whichever region is the nearest to you, you have to use that code. Once we have done that, we are good to go. Next thing what we have to do, we have to get the code to create the cluster. So this is the repository which you can refer. It is public repository, so you can clone this on the on this EC2 machine. I'll run git clone, then URL. Once you have cloned this, you can go inside this repository, and it's good. Next thing what we have to do, since we are going to be using IAC tools like Terraform to create the cluster, because what kind of cluster we want, all the configuration I have already defined in these files, right? Also, team, remember few things. If you are not in India, then make sure you are changing the region here. Again, you have to change availability zones here. These two things you have to change. Next thing you have to change in variables, make sure that this default value of the key that we use, SSH key that we are going to be using, name should be same as what key you are using. So I'm using DevOps-SAC. If I show you again, let me show you directly. if I go to EC2 dashboard, key pairs, you can see my key pair name is DevOps-stack. So whatever key you are using, make sure to put its name here, then only it will work. So, okay, so these two changes you have to do. Once you have done that, you can go ahead and use Terraform to provision the cluster. So again, we need Terraform, so we will install Terraform here. I'll copy that, and let's wait for this to complete. So now Terraform is going to be installed on this machine. Once Terraform is installed, then we are going to use Terraform to create the cluster based on what configuration we have. Okay, so Terraform is installed. Now we have all the files here, three main files we have: main.tf, output.tf, and variable.tf. So Terraform, we are going to ask Terraform, you need to use these three files and create the cluster. So we can type right this. First, you have to initialize Terraform init, which is going to download like all the required plugins, and whatever is required, it will be downloaded. So basically we are initializing Terraform, right? Once this is done, final command you have to run Terraform apply -auto-approve, which basically means that we are saying whatever configuration we have written inside this folder, use that and basically apply that configuration. Why we are writing auto approve? So let me show you why we are writing auto approve. If I simply run this Terraform apply, it's going to tell you whatever it's going to create, but at the end it's going to ask for a prompt. It's going to prompt for a question. You can see, do you want to perform this action? Basically it is asking us a prompt. But you can understand if you're running this Terraform apply command in CI/CD or somewhere like automated script, you won't be able to provide the confirmation. So what we have to do, we can use Terraform apply -auto-approve. You can basically understand that we are saying automatically just approve it and go ahead and create the cluster, right? Also you can see here there are 19 resources to be added. So we are going to execute this, and let's wait for this. Now Terraform is going to create the cluster. It's going to create so many resources. You can see total 19 resources to be added, right? It's going to create everything, roles, policies, the cluster whole configuration it's going to create. So we have to wait for it, and this might take 10 to 15 or 20 minutes, right? Based on your net speed, based on what is the size of machine you have taken. So yeah, we have to wait for it, and once it is created, then we will be continuing. So guys, as we can see, cluster has been set up. Now we have to configure it properly. So once this is done, first thing you are going to do is set up an kubeconfig file. A kubeconfig file will be responsible so that you will be able to access the cluster. So we will execute this. Next thing what we have to do is install 𝗕𝗺𝗃 so that we can communicate with the cluster. 𝗕𝗺𝗃 is a CLI, right? So that part is also done. The next thing, since we have to create two kind of resource, we have to execute 𝗖𝗍𝗃 commands also. So for that, first of all, we are going to install 𝗖𝗍𝗃. So let's do that as well. Coming to next part. So next part we have to do is execute this command, which basically is going to associate the 𝗏𝗏𝗏𝗏 provider with the cluster, which will make sure that Kubernetes resources can like provision resources over AWS platform. So we will execute this as well. Basically, Kubernetes resources can assume IAM rules so that they will have permission to create resources over there. Final thing we have to do is basically create a service account inside Kubernetes cluster that is going to manage the EBS volumes. Let's execute it. Now, if you are doing this for the first time, this might take a little bit of time. You can verify things by going to CloudFormation, because as you know, when you run 𝗖𝗍𝗃 command, it's going to send that request to CloudFormation, and CloudFormation is going to utilize the configuration defined in the 𝗖𝗍𝗃 command. Because CloudFormation is also a kind of IAC tool. So if I refresh the page, you can see it has created the service account. So this part is done. Next thing, we are going to execute these three commands, which is going to set up the ingress controller, and then it's going to set up sort manager and EBS CSI driver. So this will be responsible, or this will be required when you want to set up ingress controller for your resources, certificates, and EBS CSI drivers. So execute these commands as well. Once you have done that, then you can say that okay, cluster is set up. So this part is done, and now we can get started with setting up the Jenkins and SonarQube. Okay, so before we jump to Jenkins and SonarQube, we should be aware about the manifest files. What kind of manifest files we have to create, how many files we have to create, and what will be things, what will be resources that we have to define. So let us understand that. So guys, once you have set up the cluster, next thing we are going to go through is the YAML files. So you will be able to find it in the repository. Also make sure that you are referring to this correct branch. So first YAML file that you should be creating is the storage class. The thing is key, when you are talking about, you have to use like persistent volumes. So we have to create volumes. Which volumes? EBS volumes, right? Who is going to be responsible for that? So basically, like, what will be the configuration of volume? What will be the file system type? What will be the kind of volume? So those things we define inside the storage class resource. So here we have written the YAML file for storage class, and once we deploy this, then whatever volume is getting created, it will be based on this configuration. And EBS-SC, this will be the name of storage class which is going to create the volumes. So first YAML file you should be creating this. Second YAML file, we are talking about the MySQL YAML file, which will be our database. So in that, first we create secret. In secret we provide the value of the password. Which password? Root password. So format is going to be, first we have API version. Kind is going to be the secret because we are creating a secret resource. Then metadata, information about the name of the resource. Labels. Then we have the value. Now here you can see I have written a string data. When you write string data, when you are writing string data, that means that you don't have to encrypt the value that you provide here. You can see it's not base 64 encoded, it's direct value. Why? Because we are using string data. Second resource I am creating, which is going to be a config map, which is going to again store some information that we don't want to expose directly. So here in config map, we are providing information about name of the database, which is CRUD_app. Okay. Next config map, two config maps we are creating. First config map name is this. Second config map name is going to be this. In second config map, what we are creating a file inside which we are going to provide the commands to create the tables. This is the command that we use, right? If you remember, this is the command that is going to create a table named users, right? So and users, and it's we are putting a admin user also by default. So this will be there. So this will be the configuration available. Then we are providing configuration about the persistent volume, right? What will be the size of volume? 5 GB. And here make sure that you are writing this EBS-SC storage class name, because storage class is the one who is going to create the volume. One more thing, if I tell you in storage class, you can see here these two things: reclaim policy and volume binding mode, retain and wait for consumer. Now reclaim policy, other option that we have which can be written is known as delete, which basically means that if you have deleted PVC or the pod is also deleted, then the PV, the persistent volume, is also going to get deleted. But we are writing retain. That means that the persistent volume won't be getting deleted automatically until we do it manually. Then we are writing wait for first consumer. This basically means that volume creation will be done only if for a specific pod, when the pod is getting scheduled, right? That is, these two things are considered one of the best practices when you are talking about working with storage class. Coming back to MySQL, here we have the persistent volume. Access mode also we have written, which is read write once. That means only one node will be able to write on the volumes, right? Coming to next thing, persistent volume claim. Now the thing is when you create a pod and you want that pod should be having the data attached to a persistent volume, it can be done not directly but via persistent volume claim. That means pod will ask persistent volume claim to connect to the persistent volume. So for that we are creating persistent volume claim PVC. Same kind of information we are providing: storage class name, access mode, and the storage size. Then comes the deployment, which is going to create the pod for our MySQL. Replicas 1, that means only one pod should be created. image name we define which image we want to use. Then comes the environments. First environment, MySQL root password, whose value is going to be fetched from secret that we have created. Name of the secret was MySQL secret and key is this. So automatically inside this deployment, the value of this key will be fetched. Okay. Second thing is that we are again going to take value from config map. Name of the config map was this, key was this, which is holding the value of database name. Then we provide information about the ports and volume mounts. Now you can see these two things we are mounting. This is going to be the actual MySQL storage, and this is going to be the file which is having the commands to create the table, right? And same information we are providing here. Make sure you provide the name of PVC also, then only this pod will be able to attach to the persistent volume. Then we have service. Service is going to be of type cluster IP. In service, two important things we have: port and target port. What are they? Target port refers to the port on the container, while this port refers to port exposed by the service. Coming to next thing, we have backend. Again, here for backend we are creating a secret which is going to store the information about database password and the JWT secret. Okay, this will again, so you can see here I am using string data. That means we don't have to encrypt them in base 64. Config map. In config map, what things we provide? The database user host, username, database name, and reset admin password. This also we have to add as inside the config map. Comes the next part, deployment, where we create the pod. So we have replicas 1, that means only one pod. Comes the next part, in like container specification. So here you can provide the name of container. Then we have the image that we are going to use for container, port of the container, and then we have environment. Again, for environment we can pick up different things like db host from config map, db user config map, then db name config map, reset admin pass, that also picking up from config map. db password, it is a sensitive data, it's going to be stored inside secret, so we are picking up from secret key reference. Same thing for JWT secret also. Now here I'm creating the backend as a load balancer where port and target port will be 5000 only. Final thing, we have front end. Now front end you will be able to see, since front end is going to be the main file through which we will be able to access the application, but here you won't be able to see any information about how front end is getting connected to backend. Why? Because that configuration we have defined inside our, if I show you this file, default.the nginx file. Here we have added, it's in this configuration file we have added location/API. This basically means that when front end is going to try to connect to backend, it's going to reach out to APIs, right? So the format, if it reaches out /API/anything, it's going to be forwarded to this, and this will be resolved inside Kubernetes itself. Why we are doing this? Because this thing, this URL, this will be the service. You can see here, if I show you backend, 1 second. You can see here the backend name, backend service name is backend, right? So that's how we are going to reference it. But the thing is that if you keep it, if you try to resolve this on browser, because because the front end is going to send request over browser only. So if you try to resolve this over browser, it won't be getting resolved, because this keyword backend will be able to be resolved only within the Kubernetes cluster, right? Outside the cluster, this backend keyword doesn't make sense to anything. So for that purpose, what we have done, we have written API here itself. That means that whenever front end reaches out to that, automatically it is going to, the request is going to be forwarded to this URL, which is going to resolve within the cluster. Okay, and that is the benefit. So once we have done that, then we don't have to provide anything here. We can just provide information about the front end configuration, one pod and the Docker image and the service. Okay, so now we have to deploy this. Now this part is done. Next thing what we need to understand, the concept of RBAC. So let us understand that. So team, let us understand about RBAC, how it's going to be very beneficial for us when we want to deploy to Kubernetes. Now, as of now, what we have done, we have set up our Kubernetes via EKS, right? If I want to deploy something, we'll be needing some kind of credentials. As of now, only one credentials we have available, which is of root user for the EKS cluster, right? But you can understand that using root credentials directly for deploying anything inside EKS, it won't be best practice. So what we do, we create one user inside a cluster. This user will be of type service account. Okay, let's say I'm creating a service account named Jenkins. Once we have done that, let's say I've created service account Jenkins. Next thing I'm going to do is going to be basically create a role. Inside this role, we define permissions. Permissions means permission. I'm defining permission like the permission to deploy, to create deployment, to create services, to create pods. Those kind of permissions I defined, right? So once we have created this role, what I'm going to do, I'm going to assign this role to Jenkins. That assigning of role to the service account can be done by creating another resource known as role binding. So once we have done that, inside role binding, we define that we are assigning role, the role that we have created to Jenkins user. So once this is done, this is basically going to be like basically pointing to fact that now Jenkins can perform these deployments, right? But one thing you need to understand is this role that we are creating is of namespace level. That means that these permissions will be applied over a specific namespace only, correct? So if we have done that, like this is done that, because this is fine, like few deployments and these things can be created by Jenkins, but we need to understand that there are many resources that are existing over cluster level, not on namespace level. For example, the persistent volume, the storage class. So these are the resources that exist on cluster level but not on namespace level, and we need to make sure that Jenkins has permission to create these resources as well. So how do we do that? For that, we need to create another kind of role which is known as cluster role. So inside this role, we define permissions to create or like manage resources that are on cluster level, like PV, like storage class, these kind. So once we do that, now next thing what we have to do, we have to assign this role to Jenkins. How we can do that? By creating another resource known as cluster role binding. So once we create this resource inside which we define the cluster role that we created, we want to assign this to Jenkins. And once we do that, then this Jenkins will have permission to create resources to any namespace, specific namespace, to create resources like deployment, services, those kind of things, pods, and also it will be having permission to create cluster level resources like this as well. Now this Jenkins will have permissions more than enough to perform the deployment, and that's why we prefer to use a service account. In companies also, they are going to use service account. This whole process is known as role-based access control, because we are creating a user that will be having specific permissions only that we define, right? So that's what we are going to use today. So now we can jump and we can set up this RBAC, and then we can create the pipeline. So let us do that. So team, now we are going to set up RBAC, right? So let us do that. Before that, what I'm going to do, I'm going to be doing the deployment inside a specific namespace named dev. So let us first come out of this directory. I'm going to create one directory here. Let's call it as project. Maybe better we can call it as RBAC, right? Let us go inside it. Now let us create first the namespace. So for that you can type kubectl create ns dev, right? This will create the namespace, and now we are going to set up the service account. For that, let's copy this and create the first service account dot YAML. Now here one thing you have to change, it's going to be the namespace name, which is going to be dev in our case. apply this, and let us apply to create the service account. kubectl apply -f service account. So now service account named Jenkins has been created. Next thing we have to do is create rules for Jenkins. For that, again, you can copy a second file. You just need to make sure that you are replacing the namespace web apps. Why I'm saying so, I'm not going to be changing here, because I want everyone to put little bit effort so that you can see where we have to change, right? And you can do it by yourself. So next I'll create role.yaml, paste the contents. Make sure you are replacing the namespace, which is dev. Rest everything should be fine. Save this and apply. kubectl apply -f role. So now role is created. Now we need to assign this role to Jenkins. For that, we can create the role binding as I told you before. So let's create that file as well, rb.yaml. And here here also make sure you are replacing this namespace name, which is dev. Save this, run kubectl apply -f rb. Sorry, let me correct it again. Okay, here also we have to change the namespace name. Save this and run the apply command. So now Jenkins has permissions to create resources. What kind of resources we are talking about? Secrets, config map, PVC, services, pods, deployment, replica set, stateful set, ingresses, and horizontal pod autoscalers, right? And this much permission Jenkins service account has. But now what we need to do, we need to create cluster role, because there are resources like persistent volume, storage class, cluster issuers. These resources require the these are the cluster level resources. So now we need to make sure that Jenkins should be able to create these as well. So let us create cluster role dot YAML. Make sure you are okay, this is fine. Here we don't have to define namespace name because it's cluster level resources. So we will just save this and apply kubectl apply -f cr. Right. So cluster role is created. Now we need to assign this role to Jenkins, that we can do using cluster role binding. So let us create that as well. crb.yaml. Paste the contents here also. Make sure you are defining the namespace name, because the service account exists within the namespace only. So we will save this and run this kubectl apply -f crb. Okay. Now Jenkins has complete permission to perform different kind of things, right? There are one more thing we have to do, which is to create a token of Jenkins, which can be utilized for authentication, but to that we will come later, right? Now we can jump to create the Jenkins and SonarQube. So let us go to our EC2 platform, launch instance. To instance I'm creating of Ubuntu type, version 24.04 LTS. Size will be T2 medium, which is again quite good size for us. Key pair we have selected, and now let us select the network security group. Storage I'm giving 30 to each one of them. Click on launch instance, and let us now name this. So this will be Jenkins. See, these are just pending. That means these are the ones that we just created. So next will be SonarQube. Okay, and let us set up these machines as well. So we will connect to them. First, copy the public IP. Let us create a copy of this instance, and let us replace the IP. IP will be this. Name will be, so first machine was Jenkins, right? So let us name this and this to be Jenkins. Color we can change just for the sake of our easier access. Jenkins created, connected. Next thing we are going to set up SonarQube. So again, rename, update the public IP, which you'll be able to get from here. Copy that and paste it here. Name will be SonarQube. Okay, we can change the color for our easier access. I'm going with cyan, and SonarQube is also connected. So now let us set up Jenkins. First thing that we are supposed to run, sudo apt update. This is happening. Meanwhile this is happening, we can get the commands to set up Jenkins. So on Google you can search Jenkins installation, click on the first link, left side you can click on Linux, select the machine you are having. So since we are working with Ubuntu, we will click on here, scroll down, and we are going to be using LTS version. So I'll copy the command and come back here and wait for this. Okay, now for Jenkins setup, Java is prerequisite, so we will check Java is not present, but we get the command. So I'm going to install 21 JRE headless. Headless means there is no UI for this JDK. So we will run this, and once this is done, then we will execute the Jenkins command. So let's wait for this to complete and execute Jenkins command. Meanwhile this is happening, we can go to SonarQube and set up SonarQube as well. Command is going to be, we are going to set up SonarQube using Docker. So we'll run sudo apt update, and then we will install Docker. So for installation of Docker, we can search here as Docker installation. Scroll down, you can see we have install option to Ubuntu. So we'll scroll down. First we will execute the command to add the repository, which will be this. Let's wait for this to complete. See, Jenkins is already set up, so let us connect to Jenkins. We'll get the public IP, and as you know, Jenkins runs by default on port 8080. So we will put that in browser :8080. Click enter, and here we have to provide the initial admin password, which we can get on this location. Copy that path. You can see it's a var directory, which will be requiring the elevated permissions. So I will use sudo cat and the file name, and this is the initial admin password. We can copy that and paste it here. Click on continue. Now here select the first option. Now it's going to install all the required plugins which is needed for Jenkins to get started. So meanwhile this is happening, we can go back to SonarQube, right, and we can run the command to install Docker. So I'll copy this to add the Docker repository here, and once this is done, next command will be this to install Docker. Now as you remember, on Jenkins also we have to install Docker. Why? Because we have Docker commands that we want to execute. So I'll copy this command again, run this on Jenkins platform, and run the second command to install Docker. Okay, so on SonarQube machine, Docker is installed. We just need to make sure that Ubuntu user has the permission to execute Docker commands. For that we can run sudo usermod -a capital G Docker and Ubuntu. Okay, for these changes to be applied, we will run new group Docker, and now Docker has the permissions, right? So we need to execute command to set up Docker container for SonarQube. So let us do that. So let us run Docker command for SonarQube. We will run Docker run -d to run in detached mode, -p, port will be, host port will be 9000. Host port means port on this machine. Second port will be the container port, the port on the container, right? And then SonarQube Docker image. So it will be SonarQube :LTS community. We are using the tag LTS-community, which means we are installing the free version of SonarQube. And here we can check the status for Jenkins. You can see Jenkins is set up. So let us set up the username and the password. We can confirm the password. Full name you can put whatever you want, and email you can select. Click on save and continue. Save and finish. So now Jenkins is set up, right? We can verify the things for SonarQube. SonarQube container is also created, so let us connect to that as well. I'll get the public IP and put it here, :9000. So let's wait for this. Okay, meanwhile Jenkins is also set up, and we have installed Docker also on Jenkins. But as of now, you know, inside Jenkins server, Docker commands will be executed using Jenkins user. So what we have to do, we need to make sure that Jenkins user has permissions to do that. For that, you can run sudo usermod -a Docker and Jenkins. Now for these changes to be taking place, what we can do, we can restart Jenkins once. So I can put /restart and Jenkins will be restarted. Meanwhile, we can go to SonarQube. We have to log in. So initial admin password is admin, which we have to change in a bit. Old password was admin. New password will be something else. So we have logged into SonarQube as well. And let's log back into Jenkins. Right. Now, 𝗘𝗺𝗃 whatever things we are needed, I have already covered in previous sessions. So we are just going to copy the Jenkins file. So it will make a little bit easier for us. We have the Jenkins file here, right? Let me see. So we will copy this Jenkins file, go back here, and we will provide the name as CI/CD. Kind will be pipeline job. Click on OK. Discard old bits. We are going to keep only how many bits? 3 bits in history. Scroll down here. As I say, we have already written every step for CI previously, so we'll copy that here. Few changes we have to do, which I'll guide you in a bit. For example, the branch name, which will be this one. The branch name. So this is the branch name, right? We'll copy that, update it here. Okay. Deploy to dev-8. That's fine. This will be fine. Git leaks. So we need to make sure git leaks is also installed on Jenkins server. We can go here, search for git leaks. It's not available, but we get the command to install it. So we will install it. Side by side, we have also used 𝗕𝗏. So we are going to install 𝗕𝗏 also. So I will search here as 𝗕𝗏. Get the official page. From there, we can copy the commands to install 𝗕𝗏 as well. So I'll copy this, run it on Jenkins server as well. Next thing, what changes we have to do? This is fine. Yeah, Docker credentials. These credentials we have to add. So we'll come to that in a bit. Also, team, this stage I'll be removing because this time we are going to be deploying inside Kubernetes cluster. So we don't have to run the application via Compose. So I'll remove this. Okay, 𝗕𝗏 is done, git leaks is done. Next thing what we have to do, we have to make sure that we have Node.js on our machine, right? So I'll go to let me see, Node.js version 23. So I'll copy this name, dashboard, manage Jenkins, plugins, available plugins. Here we will search for Node.js. Install that, select it and install it on our machine. Now let's wait for this to complete. Once it is done, then we are going to configure it. So yeah, you can see it says success. So we can go to manage Jenkins, tools, Scroll down till the end, you find Node.js. So click on that, provide a name, same name that we have used in pipeline, and here you can select the version. So I'm just going to go with 23, this one. Click on apply. This part is also done. Next thing what we have to do, configure SonarQube we have to set up, right? So let us do that. I'll open it in new page, manage Jenkins, plugins, available plugins. Here search for SonarQube scanner, install that. Let's wait for this. Okay, meanwhile this is happening, we can go to SonarQube, administration, security, users, and tokens. We have to generate a token that will be used as authentication. So we'll click on generate, copy that. Now we will go to manage Jenkins, credentials, global, add credentials. Kind will be secret text because we have a token. So we'll copy the token here. ID will be sonar token. Same thing we can put in description as well. And click on create. Token done. We can go back to manage Jenkins, system, and wait for it. Scroll down till you find SonarQube servers. Click on add SonarQube. Name will be sonar. Server URL will be till 9000. Also team, note that do not put last slash, else it will cause you issues. Select sonar token, click on apply. Okay, and go to manage Jenkins, tools. So we have to configure SonarQube scanner also, which we can do from here in tool sections. Click on that. Name will be sonar-scanner. Latest version you can go with. Click on apply. Right, what things are pending now? Docker cred, I guess. Docker cred, right? So I'll copy this name, go back to Jenkins, manage Jenkins, credentials, global, add credentials, username, your Docker username, and the Docker password. Docker password, make sure you are using your own. For me, it's going to be this. Now, in ID, make sure you are putting this because that's what we have added, like used in our pipeline. You can update it, but again, since as I said, we have already covered all these things previously. I'm just going to retrace it so that it saves us some time to create the pipelines, right? Go back here. Let's see what else is pending. Okay, everything is fine. So this is the CI part. As of now, we have not added the CD part, but yeah, let us run this just to confirm that this pipeline is correct and working fine. Also team, let us install one more plugin, which will be here. We can search for stage view and install that plugin so that we can see the status of our jobs, status of the stages in our jobs properly, right? So this is done. Let's wait for this to complete, right? And now we can trigger our pipeline one time just to confirm that whatever we have written as of now, it's working fine. Let's click on build now. And let's see. So now it's going to install all the tools that we have defined, like Sonar Scanner. Then we have defined, I think, Node.js. So all these things will be installed. This will take a little bit of time. So once this is completed, then we can go with setting up the CD part of the pipeline. So yeah, let's wait for this. So guys, one more thing we had to do, which was basically about the quality gate check, right? So for that, what you have to do, you have to go here on SonarQube, configuration, webhooks, create a webhook. You can provide anything, any name you want. URL will be basically, first you have to get the Jenkins URL, copy that and paste here. Make sure no extra slash are there, and slash SonarQube webhook, right? Click on create. Once you have done that, then your pipeline should be working fine, the CI part. So let's wait for this to complete and then we can proceed with the CD part. Today we have failure because we have not yet installed the this one Docker plugin. So we will go to plugin section, available, and search for Docker. Here you can click on this Docker pipeline and that should fix the issue. So let's install it and let's wait for, okay, this is completed. Just to verify that if this is been working or not, you can go to configure, scroll down to pipeline syntax. Here search for with Docker registry. If you able to see this option, then you can say this is fine, right? And let us run one more time. Yeah, and let's wait for this. So the pipeline is successful now. Okay, and now we can proceed with writing the CI/CD stage, right? So let us go to configure. Here go to pipeline syntax, and now what we have to do here, see, as of now there is no option with respect to Kubernetes. So we have to make sure that we are installing Kubernetes plugin as well. So we can go to Jenkins, manage Jenkins, plugins, available plugins, and here search for Kubernetes. Now here first of all click on that, credentials and CLI. Install these three plugins and wait for this to complete. And once it is done, then you are good to go. Now, as I told you previously that we are going to be using Jenkins account, right? Jenkins service account to do the deployment. So how we can use Jenkins service account here? For that, we need to make sure that we have Jenkins service account token. So you can click on the same page, this repo, create token, scroll down, copy this, and go back to installer VM. Okay, and here let us create secret.yaml. So this, we are basically creating a secret for Jenkins service account, and once we do that, then we'll be able to create the token for it, which we are going to use as an authentication. So here service account name, in our case it is Jenkins, and click on OK, save this. Click now we have to apply it, but we need to make sure that we are creating the secret inside dev namespace. So we will run kubectl apply secret -n dev, right? Sorry, apply -f. So now we have created the secret, right? Now what we have to do, we have to get the token of the secret. For that we can run kubectl describe secret and the secret name. Secret name was my secret name, and we will use it in dev environment. And this token that you see, we have to copy it. So we will copy this. Once you have copied, go back to Jenkins, go to manage Jenkins, credentials, global, add credentials, and here select secret text, paste the token that you have created. You can provide a name as K8-token, that will be ID. Same thing we can put as description. Click on create. So once you have done that, you are good to go. Now we are going to use the pipeline syntax. Here we will search for Kubernetes template, and let's see. You can see this configure Kubernetes CLI, open that, and here we have to provide things. First credential, so we will add the K8 token, server endpoint, which you'll be able to get inside your AWS platform. You can open EKS and open that, and here you can see API server endpoint. So copy that, paste it here. Then cluster name, that also we'll be able to get from here itself. This is the cluster name. We'll copy that as well, paste it here. Namespace will be dev, and generate this script. Now this is the block inside which we are going to execute the command. So we will copy that, go back to our pipeline, and let us create the stage. So for creating stage, I'll copy a stage and I will create it here. First I will name this to K8 deploy remove this. And similar to Docker, we have to create a script block. So we will do that as well. Script. And here we are going to paste this part. I'll copy this, paste it here. And now here we are going to write everything. Now, before you write these steps for deployment, we need to make sure that Jenkins has the kubectl installed, right? So we will go to Jenkins machine, and here we are going to install kubectl. So let us see if we this step will work. Okay, this one we have. Let us try this. Till here to here I'll copy. Let's copy the whole thing. So let's wait for this. Okay, so kubectl is installed on Jenkins. That means our command should work now. First I'm going to write kubectl apply -f, and here we have the file inside this folder. First file we are going to deploy sc.yaml. That should be deployed inside dev namespace, so we will write that. Second thing we are going to deploy, sorry, let me write it properly. Second thing we are going to deploy, which should be MySQL. So kubectl apply -n / mysql.yaml, that also inside dev namespace. Next thing we are going to deploy, which should be the backend part, kubectl apply -f k8s / backend.yaml. See, these values I am picking up from here. Backend YAML, frontend MySQL, all those things, right? And dev. As such, kubectl apply -f k8s / frontend.yaml and dev. And after this is done, I'm going to run a sleep command so that these changes should be applied. Okay, so once these are done, final stage would be to verify the deployment. We can run here. I'm going to run kubectl get ports first. Second thing, I'm going to run the services. kubectl get svc and dev, so that we can confirm that ports are also created and services also created, right? So this should be fine now, and let us save this. Okay, let me see. Stage name should not be same. I'll write stage name as verify create deploy, right? So let us apply and let us run this. Now this might take a little bit of time, so yeah, let's wait for this to complete. So guys, we got error because you can see here one small mistake. I have written capital K, which should be small. So this should be fine now. Let us run this. And let's wait for this to complete. This may take a little bit of time. So guys, pipeline is successful. We can verify here by going into the logs, and at the end you can go to the URL of load balancer URL of frontend, put it in browser and click enter. So as we can see, it is running. Just to confirm that it's working fine, we can log in with the admin and click on login, and as we can see, we are able to log in. That means it's working fine. So yeah, now what you have to do is implement this whole thing so that like you can practice, and all these steps, commands and everything will be added in repository into this specific branch, deploy to dev k8. So make sure to refer that. Okay, the RBAC and everything, you can refer to that the Terraform repository. Rest things you'll be able to get here, Jenkins file and everything you can get it here. Okay, so yeah guys, thanks for watching and have a nice day.